Hello, and welcome to Controllerstech. This video is part 2 in our IoT project series using the ESP32. In the previous project, we learned how to configure the ESP32's Wi-Fi and station mode and connect it to a known network. After that, we set up the ESP32 as an HTTP client and send data to the ThingSpeak cloud. Today, we will take this project a step further. In this tutorial, we'll see how to configure the ESP32 as an MQTT client and learn how to both subscribe to a topic and publish data to it. We'll continue directly from where we left off in the previous video. That means the ESP32's Wi-Fi is already set up in station mode, and all we need to do now is replace the HTTP client code with the MQTT client code. Before we start configuring the ESP32, it's a good idea to test the MQTT protocol using some well-known software tools. For this tutorial, I'll be using the HiveMQ public broker as our MQTT broker. First, go to hivemq.com. Under the MQTT section, open the public MQTT broker page. Then click on View MQTT Broker. This broker is completely free and perfect for testing small projects like ours. Click Connect, and you will see all the details required to connect to this broker. Next, we also need an MQTT client, a tool that can subscribe to topics and publish messages. The ESP32 will act as one client, but for testing purposes, we'll use a second client on our computer. I recommend downloading MQTT Explorer for this. Since I am using a Mac with the M2 core, I'll download the version meant for the ARM processor. You can choose the one that matches your operating system. Once downloaded, you can either install it or run the standalone version. Inside MQTT Explorer, we need to enter the broker's details. Start by copying the host address from the HiveMQ broker page. We're not going to use a certificate for this test, so make sure to uncheck that option. Paste the host address into the host field. For the port, use 1883. Which is the default TCP port for MQTT communication. Now, go to the Advanced section to add the topic you want to subscribe to. This topic name should be unique. Since we're using a public broker, many common topic names are already taken, which could cause interference with our data. Using a unique name ensures that only your messages appear. Once the topic is added, return to the main screen and connect to the broker. At this point, you won't see anything in the subscribed topic unless a message is published to it. To test, we can publish a message ourselves. Go to the Publish section in MQTT Explorer and enter the exact same topic name you subscribed to earlier. Now, publish a random value to it. Immediately, you should see a new message appear onto the subscribed topic. This confirms that the publish-subscribe flow is working. Let's publish another value. And again, it appears instantly in the subscribed topic. If I try publishing to a completely different topic, that value will not appear here because it's outside of our subscription. With MQTT, you're not limited to just numbers. You can publish text strings, XML data, or even JSON formatted data. All right, so we have successfully tested the MQTT broker and client, and now we are ready to proceed with the ESP32 implementation. As I mentioned earlier, we will be continuing from the project created in the previous video. To keep things organized, let's start by renaming the project. Next, open the Espressif IDE and import this newly renamed project. Once the project is loaded, make sure the correct target MCU is selected. It's always a good practice to build the project at this stage to ensure there are no compilation issues. The project compiles without any errors, which means we're in good shape to move forward. Now, since we're switching from HTTP to MQTT, the first step is to remove all the code related to the HTTP client. This includes deleting any header files, macro definitions, and functions that are specific to the HTTP client and the ThingSpeak implementation. Inside the while loop, we'll also remove the existing HTTP client code. In its place, we will simply insert a delay for now, so that the loop remains functional until we add the MQTT logic. Once these changes are made, let's build the project again. The build completes without errors. So the next step is to flash the firmware to the ESP32 board and verify that the Wi-Fi connection is still working as expected. On the serial console, you can see that the ESP32 successfully connects to the mobile hotspot and even receives an IP address. For this particular project, we don't actually need the IP address, but it's a good sign that the connection is stable. With the ESP32 now able to connect to the hotspot reliably, we are ready to proceed with adding the MQTT Client functionality. We will once again make use of functions from the example projects provided by the ESP-IDF. Here is the GitHub repository for these projects. I'll include the link in the description of this video so you can easily access it. Inside the repository, go to the examples section, then open the protocols folder and navigate to the MQTT examples. You can choose any MQTT example to start with. For this demonstration, I am selecting the SSL example. Open the main file of the selected example project. We will begin by including the MQTT Client header file in our project. Next, copy the MQTT Event Handler function and the MQTT App Start function from the example and paste them into the main file of our project. Now, let's take a moment to understand and then modify these functions to suit our needs. The MQTT Event Handler is responsible for managing all MQTT-related events. These include events such as MQTT connected, MQTT disconnected, subscribed to a topic, unsubscribed from a topic, receiving data on a subscribed topic. When the ESP32, acting as an MQTT client, connects successfully to an MQTT broker, the connected event is triggered. In this event, we will call the function ESP-MQTT Client subscribe to subscribe to our chosen topic. Here, we will specify the topic name we want to use. Once the subscription request is made, we will log a success message to the console to confirm it. We can delete all other unnecessary functions from this event section to keep our code clean and focused. If the connection to the broker is lost, the disconnected event will be triggered. In that case, we will simply log a message to the console indicating the disconnection. When the ESP32 successfully subscribes to a topic, the subscribed event will run, and again, we will log a confirmation message to the console. Other events will similarly log their respective messages. One of the most important events is the data event, which is triggered when the client receives some data on a subscribed topic. In this event, we will first print the topic name to the console, followed by the actual data received. All other unrelated functions from this section can be removed to simplify the code. The MQTT error handling section is already well defined in the example, so we will leave that part unchanged. Next, we have the MQTT start function, which we will call later from the main function. Inside this function, we begin by configuring the MQTT broker details. Then we call ESP MQTT Client init to initialize the MQTT configuration. After that, we register our MQTT event handler, and finally, we start the MQTT client. For the broker configuration, we need to provide the MQTT broker address. In our case, since we are using the HiveMQ public broker, the full address will be mqtt/broker.hivem.com. We also need to specify the MQTT port, which is 1883 for TCP connections. That's all we need for basic broker setup. Inside the main function, right after the ESP32 has successfully connected to the access point, we will call the MQTT start function. Let's now build the project. There are no errors, so we can flash the firmware to the board. On the serial console, we can see that the ESP32 first connects to the network and then begins attempting to connect to the broker. The first event we see is connected, which indicates that our ESP32 client has successfully connected to the MQTT broker. Immediately after, the log shows that a subscription request has been sent. This is generated after the client sends a subscription request for our topic. Finally, once the broker confirms the subscription, the subscribed event is triggered, and we can see this success message clearly logged on the console. Now, I will use MQTT Explorer to publish a message to the same topic we have configured. Since both the ESP32 and MQTT Explorer are subscribed to this same topic, we should see the published data appear on both the ESP32 console and within MQTT Explorer. Let's go ahead and publish some data to this topic. As soon as we publish, you can see that the data is immediately received by the ESP32 client. On the console, the topic name and the data are printed clearly, confirming that the message has been received. Let's try publishing some different data to the same topic. Again, the message is instantly received by both the ESP32 and MQTT Explorer. This shows that our ESP32, acting as an MQTT client, is successfully able to receive any data published to the topic it has subscribed to. In other words, the subscription mechanism is working perfectly. The ESP32 can listen for messages, capture them, and display the details in real time. Now that we have confirmed the ESP32 can receive messages, the next step is to use it to publish data to the topic as well. This will allow our ESP32 to act as both a subscriber and a publisher, enabling full two-way communication with the MQTT broker. Let's revisit the MQTT example from earlier. Here, we can see the MQTT Client Publish function, which is used to send a message to a topic. In the example code, this function is called inside the subscribed event, meaning it runs as soon as the ESP32 successfully subscribes to a topic. However, we are not going to follow that approach. Instead, we will create a separate FreeRTOS task dedicated to publishing messages to the topic. This way, our publishing logic runs independently and at a defined interval. Since the MQTT Publish function requires the message to be in character format, let's first create a character array to store our data. For this demonstration, we will send random integer values between 0 and 99 as our message data. To convert these integer values into character format, we can use the sprintf function. Once the data is formatted, we call MQTT Client Publish to send the message to our chosen topic. Here, we will specify the topic name and use the array we just created as the message data. We can set the length to 0, which allows the API to automatically calculate it. If the message is successfully published, the function will return 0, and in that case, we will log a success message to the console. If it fails, we will log an error message along with the message ID to help with debugging. We will configure this task to run every 2 seconds so that data is sent continuously at a regular interval. Now, there's one detail to take care of. The client parameter used in our publish task is not defined within this task scope. Since the client is created inside the MQTT_start function, we need a way to access it globally. To do this, we define a global MQTT client handle. Let's call it MQTT Client at the top of the project. When the client is created in the MQTT start function, we assign it to this global variable, allowing us to use the same client instance in other functions, including our publish task. With this setup, our MQTT Publish task is ready. Now, we need to decide when to start it. The ideal place is when the MQTT event connected event is triggered, which means the client is connected to the broker and ready to send data. Since our current goal is to test publishing, we will comment out the subscription part for now. Instead, in the connected event, we will create a new task with following parameters. The task function is MQTT Publish task, and also give the same name to it. Keep the stack size at 4 kilobytes. There are no parameters for the task, and make sure the priority is set to 5. This ensures that as soon as the client connects to the broker, the publish task starts and sends a new message to the topic every 2 seconds. Let's build the project. The compilation is successful, so we can now flash it to the ESP32 board. Opening MQTT Explorer, we can immediately see the messages published by the ESP32 client appearing every 2 seconds. An added bonus is that MQTT Explorer can plot these incoming values on a chart, letting us visualize the data changes over time. With this, we have successfully demonstrated how to use the ESP32 as an MQTT client that can both subscribe to a topic and publish messages to it. That's all for this video. I hope the explanation was clear and easy to follow. We will continue exploring more ESP32 IoT-related projects in the upcoming tutorials. You can download the complete project from the link provided in the description. If you have any questions or run into issues, feel free to leave a comment. Thank you for watching, and have a great day ahead.